All right, so we're going to go for the second team today, and we're going to talk about chemical changes. I think they're a little bit more fun because they do cool reactions. So, chemical change indicators. Put a big star next to your notes with these. These are very, very important. I'm absolutely going to torture you with these for the next couple weeks, so here we go. The first one is a big color change, and I thought, what a good one for this time of the year is to have all of the leaves that are coloring. That's a big color change.
And that's a big change, because what's going on there is, if you remember back to biology last year, or you'll get to it, is photosynthesis. And the leaves are green all summer because of photosynthesis, but as the waves of light get shorter, they change colors.
Right, so I thought this would be a good picture for you. You could also see the production of gas, and the way you would see that would be bubbles. And then the last one, which is a little bit new, this is going to be a new word for you guys, is forming a precipitate. And I'll teach you what that big fancy word means. So here we go. So first indication is a big color change. And what I'm showing you here in the picture is yellow and white, and when you mix them together, you get red. What do you have there, Mr. Burke?
So if you know anybody has a pool, you got to check your pool to see what its hardness, pH, chlorine before you use it. So you buy one of these test kits and you get these test strips and you dip the test strip in the pool and it changes colors and you match it up. That color change on this strip is a chemical change.
Perfect. Great example. So another one that you will see is the production of gas, and you'll see bubbles. And this is an acid and a base reaction that you're seeing here. And that means that a whole new substance is being produced, and that's the gas, and that's why you see the bubbles.
Good example of that is combining vinegar with baking soda.
Yeah, always fun to do.
Always fun to do.
Always fun to do in the kitchen. And then the last one, this is your new word that I want you guys to write down for me. So this is a precipitate, and a precipitate is actually solid. And what happens is that it forms when you put two liquids together. So if you guys look up at the picture up here, you've got a clear liquid combining with another clear liquid, and you see that yellow solid that's falling out. That's called a precipitate that's falling out.
It's not magic. It's a chemical reaction.
Absolutely. So we wanted to show you guys some examples, and we actually just had a birthday cake for my mother. Her party was this weekend. And baking a cake is a great example of a chemical change.
So you combine all the materials together and they're liquid, and you put them in the oven and you add heat, and they turn to solids and they get bigger and taller and they change shape and size, and you get air pockets, and that's a big time chemical change. And if you're going to be good at baking, you got to be careful how you put things together, because chemistry requires precise measurements.
That's right. Accuracy and precision we always talk about. So there's a couple other examples here. Food being digested. Iron nail rusting, and we already talked about the leaves changing color. So what we have for you here are two physical changes. A physical change and a chemical change. And I wanted to show you one using the same substance. So I'll do the physical change, you do the chemical?
Sure.
Okay, so the physical change here is just chopping wood or cutting in half. We have a big wood pile out back. He does all the chopping, not me. And this is just a physical change because it's still wood. It's just in smaller pieces. How about a chemical change?
Well, then you get a chemical change where you burn the wood. So what you do is you get the wood hot enough that you start getting vapor to come off the wood. It seems strange, but it's true. Vapors are coming off the wood, and the fire is actually burning that gas. And so the wood is changing from a solid to a gaseous state, and then it's getting burnt, and you see the yellow flame, much like you see a candle burning. Candle burning, chemical change.
Very good. That's right. Anytime you see flames is a good indication of a chemical change. go. Oh, you got one more for me?
I got one more for you.
Okay.
It's another one you might find around the house. So if you have fish, you have ammo chips. Ammo chips keep the fish healthy, and what's going on is that the ammo chips cause a chemical change in the water, and it helps keep the tank clean.
Very good. Our fish appreciate that. We have a 30-gallon freshwater tank here with about, what do we got, 10, 15 fish? Yeah, I don't know, something like that. All right, so here we go. Summary time, people. Hope you're ready. I would like you to please compare and contrast physical versus chemical changes. And then more importantly, how will you tell the difference between them? Literally, what will you see? What will you look for? What are you going to look for?
If you see fire, bubbles,
Yep.
color changes,
Yep.
yeah, chemical.
Chemical change, absolutely. And make sure that you give yourself some examples of both. Those will help you quite a bit in the lab today. So this is Mrs. Burke and
Mr. Burke.
That's right, signing off saying go Boston, go Red Sox, and make sure you guys turn in those summaries.